Okay, so good day, grade 8 Makati Science High School students. Okay, for this lesson, this is going to be our last lesson. This is going to be our last lesson for the third quarter, or our eighth lesson. So it's going to be about angles of elevation and depression. And also, we will discuss laws of sines and cosines in different videos. But for this video, we're just going to be discussing the applications of the trigonometric ratios. Diba? We've learned 6 trigonometric ratios during our classes, during our synchronous classes. We have the SO, Ka, Towa, Cho, Sha, Kao. Okay, we have that acronym for the 6 trigonometric ratios, and we're going to try to apply those 6 trigonometric ratios in this topic for angles of elevation and depression. Okay, so let's start with this problem. Okay, number 1, we have here Anastasia and Daniel were assigned to raise the flag in their school, causing a shadow to be cast on the ground. So this is the shadow for that question. The distance from the base of the pole, okay, here, to the tip of the shadow, this one, is equal to 50 feet. Okay, so the distance between the tip of the pole and the shadow, okay, from the base of the pole, which is 50 feet, and the tip of the shadow is equal to 50 feet. And when there's daylight, the sun's ray makes an angle of 38 degrees. So this is a very important information, the 38 degrees. So how tall is the flagpole if we're only given these indirect measurements? Okay, so for this problem, we call this type of measuring as an indirect measurement. We're going to measure the side measurements of specific or real life objects just by using the indirect measurements that we have here. And what are the indirect measurements that we have? We have the angle measurement, which is 38 degrees, and we have the shadow measurement, which is 50 feet. We don't necessarily use a big ruler, or we didn't use a big tape, tape meter tape, okay, to find the measurement of the height of this flagpole. Okay, so for this problem, we're going to be using the trigonometric ratios that we've learned. So we have 6, right? So we have So, Ka, Towa, Cho, Sha, Kao. But for this problem, we're just going to be using the 3 most common. And also for this entire lesson, we're just going to be using the 3 most commonly used trigonometric ratios. We have the So, Ka, and the Towa. For this problem, we also have to analyze what we're looking for. We have the opposite side of the angle, and also we have to analyze as well the given information. We have the adjacent side of the angle. Okay, so always remember, guys, the angle is your reference point. Wherever the angle is placed, that's the basis, or that's your reference for choosing a specific trigonometric ratio. And for this problem, the most probable or the most likely trigonometric ratio that we can use here needs to have an opposite on its formula and an adjacent on its formula. So therefore, since this has an hypotenuse, the saw trigonometric ratio will not be used, and also the Ka. So therefore, we're going to use the TOA. Tangent theta, tangent theta is equal to the opposite side all over the adjacent side. And since we're given here the value of theta, so that's equal to 38. So tangent of 38 is going to be equal to the opposite side, which is the height, and which is missing. So we're just going to write there h, all over the adjacent side, which is 50. And therefore, we can now solve for the height of the flagpole using indirect measurement. So how cool is that? Okay, so we're gonna use cross multiplication to get the height of the flagpole. Okay, so for this one, that's gonna be, since this is tangent 38 all over 1, we can write 50 tangent of 38 is gonna be equal to the height. And if you try to evaluate that on your calculator, you can use scientific, or you can use the one that you found in the internet, online calculator, or maybe your smartphone calculator, the app on your phone, that would do as well. So 50 times tangent 38, that's gonna give us approximately 39. Okay, that should give us approximately 39.06. Okay, so therefore the height of this pole is approximately 39.06 0.06 feet. So that's a tall pole. It's a very tall pole. It's kind of like four stories tall. If one story or one floor is 10 feet, so if you're going to try to estimate, so this flagpole is around 4 stories tall, which is the common one of the common standards for flagpoles here in the Philippines. Okay, so for this problem, okay, we have here the height of the flagpole is equal to 39.06 feet, and we solve this problem by using indirect measurement and the trigonometric ratios for this one. And that's how we solved it for this problem.